You are standing outside on a clear night, neck craned back, staring up at the sky. Maybe you do this on a camping trip, maybe it's a power outage in the city, and for once you can actually see the stars. And somewhere up there, maybe you read it in a headline, maybe a teacher told you, maybe you watched a documentary. Somewhere up there are black holes, collapsed stars so dense that nothing, not even light, can escape. Gravity so strong it swallows space itself. That's what you believe. That's what everyone believes. But here is a question that nobody asks out loud. If nothing can ever escape a black hole, not light, not information, not anything, then can a black hole ever actually finish forming? Can it ever fully exist? Because the answer to that question is going to bother you for a long time. Let me be fair to the common sense version, because the common sense version is pretty good. A massive star burns through its nuclear fuel over millions of years, and one day the fire goes out. There is nothing left to push back against gravity, and gravity, as you know, never stops. It never gets tired, it never takes a break. So the outer layers of the star come crashing inward with enormous force, and the core collapses under its own weight. If the star is massive enough, and some of them are absurdly massive, tens of times heavier than our sun, then nothing can stop the collapse. Not neutron pressure, not electron pressure, nothing. The matter just keeps compressing denser and denser until it reaches a point of infinite density, a singularity. And surrounding that singularity at a certain distance is the event horizon, the point of no return. Step inside and you are done. The escape velocity there exceeds the speed of light. And since nothing moves faster than light, nothing comes out. And you would be right to think that, because every part of that story is grounded in real physics. Einstein's general relativity predicts it. Chandrasekhar worked out the mass limits. Oppenheimer calculated the collapse. The evidence for these objects is overwhelming. We have photographed their shadows. We have seen stars orbiting invisible massive points at the centers of galaxies. We have detected the gravitational waves from two of them crashing into each other. So the black hole is real. Of course it is. The question is not whether the physics is happening. The question is whether, from the outside universe, it ever finishes. If you want to understand how the universe actually works, not just how it looks, but how it works, hit that subscribe button. Let's find things out together. Here is where it starts to come apart. One of the most solid, most tested, most reliable things in all of physics is the speed of light. Nothing moves faster. That is not a limitation of our technology. It is not something we might engineer around someday. It is woven into the structure of space-time itself. And what general relativity tells us, and this part has been verified, this part is not speculation, is that gravity warps time. The stronger the gravity, the slower time runs. This is not an illusion. Clocks on the ground run measurably slower than clocks on satellites. We have to correct for this in GPS systems, or they drift by kilometers a day. Gravity and time are not separate things. They are tangled together at the root. Let me give you a way to see this. Imagine you have two identical clocks, identical in every way, perfectly synchronized. You put one in your kitchen and you strap the other one to a rocket and send it to hover 600 miles above the Earth's surface. Come back a year later and compare the two clocks. The one that stayed in the kitchen ran slightly slower, not because of vibration or temperature or battery drain, because the one in the kitchen was sitting deeper in Earth's gravitational field, and deeper gravity means slower time. The difference is tiny, microseconds, but it is real, it is measurable, and it accumulates. Now scale that up, not Earth's gravity, not 600 miles. Take gravity so strong that even light itself can barely climb out. Take gravity so strong that the escape velocity at a certain radius reaches the speed of light itself. At that radius, the event horizon, the time dilation factor doesn't become large, it becomes infinite. Infinite time dilation means time, from the outside observer's perspective, stops entirely for an object at the horizon. Do you see what happens? The horizon is not a place in space you can point to and say something is sitting there. It is a limit, an edge that the mathematics says requires eternity to reach. Now imagine you have a friend, and your friend is an astronaut, and this astronaut is falling into a black hole, not a small one, a supermassive one, so the tidal forces won't tear them apart immediately. They fall feet first toward the event horizon. From their perspective, from inside the reference frame of the falling astronaut, nothing strange happens at first. They cross the horizon, they do not feel a special moment, they continue falling. The physics inside their capsule behaves normally. That is one thing general relativity tells you. But here is what you see from outside. You are watching through a telescope. As your friend falls closer to the event horizon, something begins to happen. The light reaching you from their capsule is climbing out of a deeper and deeper gravity well to get to you. And as gravity warps time, the light is redshifting, stretching to longer wavelengths, losing energy. The image dims. But more than that, the closer your friend gets to the horizon, the more time dilates for them relative to you. Their clocks run slower and slower from your perspective. Their fall appears to slow down. They seem to decelerate as they approach the horizon, and then, and here's the part that keeps me up at night, they never arrive. From your perspective, watching from outside, your friend asymptotically approaches the event horizon and never crosses it. Their image freezes. It redshifts into oblivion. They fade out like a dying ember, but they never cross. They never reach the singularity. They never fully fall in. Do you see what happens? The event horizon, from the external universe's perspective, is a place that takes an infinite amount of time to reach. Stay with me, because this means something enormous. When a star collapses to form a black hole, what you see from outside is a star that is shrinking, contracting, its light redshifting, its surface gravity climbing towards something impossible. But the surface of the collapsing star, just like your astronaut friend, can never actually cross its own Schwarzschild radius, its own event horizon, in any finite amount of time as measured by the external universe. The collapse takes forever. From our clocks, from our frame of reference, from the only frame of reference the rest of the cosmos shares, the black hole is not a finished object. It is a process, an asymptotic approach, a thing that is forever becoming but never fully is. Oppenheimer and his student Hartland Snyder calculated this in 1939. Before the war, before computers with pencil and paper, they solved Einstein's equations for a collapsing sphere of dust and found exactly this. An outside observer would watch the collapse slow down and freeze. The infalling matter would approach what they called the Schwarzschild surface, what we now call the event horizon, and never reach it. Not in a billion years, not in a trillion, not in any finite time. They called these objects frozen stars. The surface of the collapsing star appears to halt and hang there, frozen in time, for eternity. And what we detect, what we photograph, what we measure, what we name, is the gravitational and electromagnetic signature of that frozen approach. Now here is the proof ladder, and I want you to follow each step. First, time dilation near a massive object is real, measured and quantified, not theoretical, real. Your phone knows about it. The GPS satellites compensate for it. Second, the event horizon of a black hole is a region of extreme gravity where time dilation becomes extreme, where mathematically the time dilation factor goes to infinity at the horizon itself. Third, if time dilation is infinite at the horizon, then reaching the horizon from the perspective of an outside observer requires infinite time. Fourth, infinite time has not passed. The universe is approximately 13.8 billion years old. That is a large number. It is not infinity. Therefore, from the frame of reference of the observable universe, no event horizon has ever been fully crossed. No singularity has ever been reached. The collapse is ongoing. What we call a black hole is, technically, a gravitationally frozen collapse, an object so warped in time that its interior is causally disconnected from us, not because it exists somewhere, but because it hasn't finished not existing yet. The physicists who grappled with this most honestly gave them a more accurate name, frozen stars, or sometimes gravitational collapse objects. The name black hole, coined by John Wheeler in 1967, a brilliant piece of branding, replaced frozen star, and something was lost in that replacement. The name black hole implies a finished thing, a container, an object with an inside. Frozen star implies what the mathematics actually shows, a process, a limit, an asymptote. Now I want to take this deeper, because if the event horizon is never actually formed from the perspective of the external universe, then what is the interior of a black hole? Where is the singularity? The singularity, the point of infinite density that classical general relativity predicts, exists, if it exists at all, only in the future light cone of the collapsing matter. It exists inside the horizon. But if the horizon is never crossed from outside, if the interior of the event horizon is a region of space-time that our universe's causal history has not yet reached, then the singularity is not a place. It is not a location in space. It is a moment in time that the rest of the universe hasn't gotten to yet. This is the part that connects black holes to something much more uncomfortable. What is real? The physics of general relativity is built on a beautiful principle, that the laws of physics must hold in all reference frames. No reference frame is more correct than any other. The astronaut falling through the horizon has a valid reference frame. From their perspective, they cross. Things happen inside. There may be a singularity somewhere in their future, rushing toward them. Their experience is real. But your reference frame, standing outside, watching, is also valid. And from yours, they never cross. The interior of the black hole does not exist yet in your causal history. Both are true. Both reference frames are physically valid. There is no universal now. There is no fact of the matter about whether the interior of a black hole exists right now. This is not a paradox to be resolved. This is the universe as it is. Think about what that means for your own existence. You have always assumed, without ever questioning it, that there is a shared present moment. That while you are reading this sentence, somewhere a star is exploding, somewhere a planet is forming, somewhere a civilization might be thriving or dying, and all of it is happening now, simultaneously, in a single universal instant. You assumed reality was like a stage and every actor on it shared the same moment. But special relativity destroyed that assumption 100 years ago, and general relativity made it worse. There is no shared present. The present is local. The now that you inhabit is your now, carved out by your specific position and motion in space-time. And this is not philosophy. It is the reason your phone's GPS works at all. And here is the implication that is genuinely hard to sit with. If there is no universal now, if time is not a river flowing at the same rate for everyone, then existence itself is reference frame dependent. What exists depends on where you are and how you are moving. The interior of every black hole in the observable universe is real to some observers and has not yet happened for others. Our universe contains regions of space-time that are causally inaccessible not because of distance, but because of time itself. Because infinite time must elapse before those regions become part of our story. The universe has an inside that its own outside cannot reach, a locked room that takes forever to enter. And we built the lock ourselves out of mass and gravity and the finite speed of light. Let me bring this back to your body. Right now, in this moment, the light you are seeing from the night sky left those stars years, decades, centuries ago. Some of those stars have already exploded. Some of them are already collapsed. From your reference frame, they are still burning. You cannot know what is happening there now. You cannot even coherently define what now means for a region of space separated from you by light years. What exists in the universe is not a clean, defined snapshot. It is a web of causal connections, of light cones touching and overlapping, of reference frames that each carve out their own slice of space-time and call it reality. You are not seeing the universe. You are seeing your universe, the slice of space-time that your particular world line has cut through. Every photon hitting your eye right now is a message from the past, from a source that may no longer exist in any form. You are surrounded at every moment of your waking life by a kind of cosmic lag, the universe as it was, not as it is. And somewhere at the center of every massive galaxy, including the one you live inside, there is a frozen star that has been asymptotically approaching its own horizon since before the Earth existed, and which, from your causal frame, has still not finished collapsing. Its gravity is real, its influence is real, the stars orbit it, but its interior, the singularity at its heart, that is still in the future, still becoming, still not yet. So black holes don't exist, not in the way you thought. They exist the way a wave exists on the ocean, as a pattern, a process, a persistent structure that never resolves into a final state. The water molecules in a wave never stop moving. The ocean never finishes producing the wave. The collapsing star never stops falling. What we call existence, even for something as dramatic and final sounding as a black hole, turns out to be an ongoing process observed differently by every observer in the universe. Here's what I find beautiful about that. Every frightening thing about black holes, the inescapability, the infinite density, the destruction of information, the crushing singularity, every one of those horrors is locked away in a future that no external observer can ever reach. The universe has a kind of mercy built into its geometry. The most violent events in cosmic history are, from our reference frame, permanently incomplete. The collapse never finishes. The singularity is always one asymptote away. What we see is not a finished trap. It is gravity, doing what gravity does, on timescales that approach but never reach infinity. And maybe that is the deepest thing general relativity tells us about the nature of reality. The universe does not deal in finished states. It deals in processes, in approaches, in tendencies. What we call objects, a star, a planet, a person, are not things. They are verbs. Slowly or quickly or over timescales no clock will ever record. Everything is mid-collapse. Everything is mid-formation. Nothing has finished arriving yet. The universe does not end things. It only asymptotically approaches endings forever. If this twisted your brain a little bit, good. That means it's working. I'll see you in the next one.